Hello everyone, welcome to Chanakya IAS Academy. Today we are going to start a new initiative of our YouTube channel that is named as Cyclopedic Module. In this segment of this initiative, we will be picking some relevant research topics or news related news articles and study projects related to our science, technology and environment syllabus. This would help us enhance our mains material as well as put add-on in our prelims preparation. Okay. So our first topic that we have taken from the Hindu newspaper is about a research done by an international team from India, Japan and Europe, and what they have given in this result, what they have given the output about this in this research done by the international team. They have conducted some monitoring operations using the pulsar observations in the galaxy so that they could detect the presence of gravitational waves. Okay, so let us know something more about this study and some core concepts related to it. Important thing here is that India has played a vital role in detecting the universe's vibrations. Why? Because they have used the data from the giant meter radio wave telescope, which is located in Pune, Maharashtra. Now, what is the context of this particular module is that an international team of astronomers from India, Japan and Europe has conducted the study to detect the presence of gravitational waves using pulsar observations. We'll see on later what are these pulsars and what are these gravitational waves. First, let us just go through the study and its results. Okay. Another important thing that I have mentioned you that India's giant meter radio telescope has been used, and it is one of the world's 6 large telescopes. Some other are also there, like those in Netherlands, Germany and Manchester. Okay, one of them is located in Pune, India. And what they have found in the study is the presence of gravitational waves. Now, let us go in depth about the results of this study. What it has provided that there is a hint of evidence about the relentless, persistent vibrations that are going on in the universe, on the fabric of the universe. Just like a curtain or a bed sheet or a carpet on the floor, there is a fabric of the universe on which this humming kind of vibration, small minute vibrations are going on, which are caused due to gravitational waves. And how these vibrations are caused by gravitational waves? Because they are a very low frequency vibrations. Why? Because the gravitational waves, they are very hard to detect on in the universe, because these vibrations are caused due to ultra low frequency vibration. Okay, why they are very ultra low? Because they have the radio spectrum. These relentless vibrations that are caused by gravitational waves are caused by ultra low frequency gravitational waves. Why they are ultra low frequency gravitational waves? Because they range in the spectrum of 300 Hz to 30 kilohertz. Okay, these gravitational waves are so low and very minute, so that they are very hard to detect by the astronomers, researchers or any observations being done throughout the universe. Okay, and how are these waves caused? These waves are caused or expected to originate from massive or big monstrous black hole pairs. You know, black hole is something that don't even allow the light to escape from it. Okay, so there are pairs of black holes that come together, dance with each other, just like they are done. People used to dance on a big ball party. A lot of things are surrounded around them. A lot of monitoring elements are there in the universes. So these elements, when come close together, they cause vibrations. They rotate, they move around. Their movements causes vibrations. So this is how a black hole pair is, which is very big, very massive, very monstrous, has caused these vibrations. Okay. Now, what we need to know, one more thing we need to know here is that there are a lot of signals that move throughout the universe. Different kinds of signals, very different size, different magnitude, different frequencies. So some of them, it was also noted in the study that some of them move very rapidly, very fast. Their speed is enormous, and some of them move at a slow pace. They take a slight delay. Okay, this was also notified or noticed in this study. And these vibrations that have been detected on the fabric of the universe is like a humming sound that is produced through bees or flies, and these sounds have a frequency nanohertz. Okay, this frequency of humming in the universe is in nanohertz. And these we have discussed that these vibrations that are produced due to presence of gravitational waves, and also some pulsar observations that are spread that are randomly distributed throughout our galaxy, and their signal irregularities have also contributed in the detection of this gravitational waves. Now, what is the significance of this study? What we need to know here about this study is that first most important thing is that for the first time an Indian telescope data has been used to detect or hunt these gravitational waves that has been taken from GMRT in Pune. Another important thing is that it has played a very vital role in opening a new astrophysical rich window that has given impetus to the research and the observations being done by the astronomers and scientists to unravel the mysteries of the universe. Okay, scientists have got a lot of information and lot of data they could work upon to get things clear and learn more about these gravitational waves to make the human life better. Okay, now let us know some concepts related to these study one by one. Very important thing that we need to know here is about pulsar. What is a pulsar that has been used to detect these gravitational waves? It is actually a neutron star, a very rapidly rotating neutron star. What is a neutron star? It is something, it is a kind of very massive star that has ran out of fuel but still emits some light. Okay, so these pulsars are actually embers of a dead star. Embers of a dead star means you can take it as a piece of wood or charcoal that has been burned, but it still has light that it emits and fuel light that it emits, but its fuel is over and it has collapsed. Okay, these pulsars, these are randomly distributed throughout a galaxy, and they act like a cosmic lighthouse because they are emitting radio beams. They have ran out of fuel, but they still emit radio beams, and thus they act like a cosmic lighthouse on the galaxy or in the universe. Okay, and that is why they have been taken as consideration to monitor the presence of these gravitational waves, because they are spread throughout the galaxy, and that is why these elements could point out the presence of the waves coming from there. Gravitational waves, we know these are actually kind of ripples on the fabric of the universe, on the platform of the universe. Just like we throw a stone in the water and ripples are created, these are somewhat like ripples in the base of the universe. Okay, of the universe or space and time. These are extremely weak. They have a very long wavelength and very low frequency. Why we are unable to detect gravitational waves, or why it is very difficult to detect them or hunt them, is because they have a very long wavelength, they have very low frequency, and they are very weak. Okay, but still scientists or our astronomers have succeeded in this experiment, and in 2015 we have detected presence of gravitational wave for the first time through the LIGO project, that is the Laser Interferometer Gravitational Wave Observatory. This research was initially done in Louisiana and Washington DC. Now this is also conducted by India, LIGO project in India in Hingoli district of Maharashtra, and a new LIGO project is being made in Kagra, Japan. Okay, but for the first time it was detected from Louisiana and Washington DC. Another thing that these gravitational waves or detection of gravitational waves is based on the concept of Albert Einstein's theory of relativity. You know, Albert Einstein has won Nobel Prize for this theory of relativity, and what it says that an object that has ample amount of mass, it warps the space and time. Warps the space and time means it, whatever things or objects comes near this that of a universe, it warps them. It either twists them, either turn them, or make it out of shape, so that it could not sustain for a long time around this very heavy object. So this theory of relativity has been aligned with the gravitational wave to detect them, because this is somewhat the gravitational waves are doing, because they are caused with the massive black hole pairs. And what black hole pairs does, they are so enormous, they are so massive that and they don't even let the light to escape. You can just think of the intensity it has. Nothing else could escape it, no object could survive around it. Everything get warps in the time and space. Okay, now this is something about the LIGO project. As I told you, it was first done in Louisiana, then Washington DC. Third project was LIGO India, that is located in Hingoli district of Maharashtra, and it was built by Department of Energy, Department of Atomic Energy, Department of Science and Technology, under an MOU with the US National Science Foundation. This was a collaborated project between India and USA. Why it has been built? The entire purpose or the wholesome purpose of this project was to detect gravitational waves in the universe, and they are designed to measure changes of several order and several magnitudes on the fabric of the universe. Okay, so this is a layout, a diagrammatic representation how the LIGO observatory is seen. It is an L-shaped module. These L-shaped lines, they act as antennas. It has a distance of around 4 kilometers. They act as antennas, just like you can see it here. They pass through an interferometer. These are the laser beams going through it. They interact. One beam is coming from this side, another is this. They have opposite charges and they create a pulse. When they interact, they create a pulse, and this pulse, when this pulse is detected, we could figure out that yes, there is a presence of wave. Okay, this is the photo detector where the pulse is detected. Now, the very important thing in this entire concept, the Giant Meter Radio Wave Telescope, which is located in Maharashtra, and whose data has been collected to detect the presence of gravitational waves today. What is a radio telescope actually? Radio telescopes are those telescopes that operates in radio astronomy. Unlike the optical telescopes that uses the light waves, which could only be used in daytime, but radio telescopes are something that can be used in daytime and as well as in the night time as well. Okay, so this radio telescope, it has a diameter of 45 meter, and what it is composed of, it is a kind of array. It is a kind of array of 30 such telescopes that are steerable and parabolic. Steerable and parabolic means, steerable means we can move it or use it in any direction or in any alignment according to our needs. And parabolic means the structure it shows. See, this conical structure of the radio telescope, it has a base, it has a cone like shape, it is embedded in a topology kind of structure, so that they could transmit the messages, data, or receive signals in through the sky. Okay, it functions at the meter wavelength part of the radio spectrum. We know there is a radio spectrum and there is a meter wavelength. This particular telescope functions at the meter wavelength. Why? Because the meter wavelength has minimal interference of human. Man-made interferences are very minimal in this radio spectrum, and that is why we have considered this meter wavelength to use or take observations from the radio telescope. It was created by the National Institute of Radio Astrophysics, Tata Institute of Fundamental Research, that is also located in Pune. And one important concept in this is that it is based on a SMART concept. SMART concept here is not something that we know about smart cities or smart solutions in urbanization and urban infrastructure. This SMART concept is about broadcasting and networking. It stands for stretch mesh attached to rope truces. The stretch mesh attached to rope truces is about this topology structure. This topology structure that we use to transmit and receive signals and create, take observations or do analysis over that. This topology structure, mesh structure, is used in this broadcasting and networking. Okay, so that is why this particular radio telescope is based on SMART concept. So that was all for today. I hope you liked this little video about the giant meter wave radio telescope and its study that has been conducted by an international team. Anything else you would like us to deal with or make video on, or help you clear the concepts of in subjects of our science, technology and environment section, please let us know. Your suggestions are very well appreciated here, and thank you.